Now there is a column shortening, what I discussed with you. So actually generally this happens, actually yeah, most of the times, yeah, or this is exterior, let's say. So this is your exterior column. Interior columns, you know that in high-rise buildings, let's say there is a high-rise building like this, or let me show you. Let's say now in high-rise buildings you will see that this middle column, as there is a load from right side, left side and other sides, this P is very high. So P is more, axial load is very high in this column, and in this column P is less because there is less contribution. Now if the building is, let's say 30, 40 or 50 story, 100 story, then you will definitely see that there is a possibility that this column will shorten. Shorten means it will actually shorten. See this. Generally, whatever we design for 10 story, 15 story, 20 story buildings, we ignore this point. Actually, we ignore this. But if it is a high-rise building, 50 story, 40 story or 100 story, then you cannot ignore. There is a possibility that the column height will reduce internally, axially. And as see, you can see there is a delta here. Okay. Due to that, there will be more moments at this joint. See this, there are moments in this joint and there will be more stresses in the columns and beams, and there is a possibility of failure also. There is one more possibility. What will happen if this is the case? See the deflected shape here. Now to understand deflected shape, why it is very much important, I say, because you can understand the behavior of the structure through deflections. See, we cannot understand the stress, we cannot see the stress, we cannot see the force, but we can see the deflections with our eyes. And why this is very important, deflection term, because you can see the deflection and you can understand the reason or cause behind the deflection. So as a human being, you cannot see the stress, you cannot see the force, but you can definitely see the deflection. That's why deflection study is very much important. Many times people find structural engineering difficult because they cannot see the deflected shapes. Why they cannot see? Because they are not trained in the education system to see the deflections. Okay. So the focus is not given much on the deflection. See, major focus is given on the bending moments, stresses, design of the steel and all this. We ignore this part somehow, I don't know the reason, but that is the problem. So if you see, now if you see this deflected shape like this in the building, what will happen? क्या होगा अगर ऐसे हुआ तो? You know that there are walls रहेंगे ना यहाँ. So there is a possibility that there is a wall here, brick wall. Either there is a brick wall, let's say there is a brick wall here. अभी ये पहले straight brick wall रहेगा ना. There is a brick wall which is straight, horizontal ऐसे. Then what will happen to this brick wall? There will be cracks in the brick wall. See this will be cracked because of this tension will develop here. Why this tension is developed? Because of this deflection. See the reason, you should know where is the cause, starting point. It deflected, so it got stretched. It stretched, brick wall stretched, there is a tension. There is a tension, there is a crack. So the reason was the deflection. Why the deflection? Due to more axial load. Why more axial load? Because there are a lot of floors and it is internal column or mid column. So comparatively, compared to this end column, this is more. Okay. See the reasoning behind this. So you should be able to see the structure this way. Now definitely such kind of cracked wall, we will not stay in such kind of structure. अगर उसमें crack आया brick work में, तो you will feel that structure will collapse. Structure गिर रहा है क्या, ऐसे दिमाग में आएगा. So there will be fear in your mind and you cannot really stay in such kind of structures. Okay, definitely. So this is the case. There is one more point here is, Partition walls. Okay, so here it is shown clearly. There is a brick here and there are cracks. Now in many times there are, if you see the glazings in the high-rise buildings or commercial buildings, there are external glazings, and glazing means this is a glass. Okay. Now say if this is the glazing column and glazing beams, let's say steel beams are there, steel beams and steel columns, and if there is a deflection like this, what will happen? The glass will crack or it will break. We cannot say crack, actually generally glass breaks and there will be collapse of the glass partition, right? The reason, definitely this deflection. That means whatever this deflection is there, vertical deflection, it should be within limits. Within limits, where is the limit given? In the IS code. So as an engineer, your aim is to calculate the deflections, calculate deflections in the members, and whatever deflection, let's say calculated is delta cal, should be less than delta permissible given in the IS code or any other international code. Okay. So if this is the case, then your structure is safe from serviceability point of view, from deflection point of view. So there will not be any crack in the walls, there will not be breaking of the glass in the glazing. So you should know how to calculate the deflection. So there are formula for the deflection calculations, or softwares will calculate the deflections, and there are codes, clauses given in the code regarding permissible deflection. So try to understand such importance in this. Now you might have seen the different pictures where there were deflections. This is due to the earthquake. Even in footing also there is a possibility of deflection like this. Now can you tell me, if you want to reduce the deflection of the footing, what you will do? अब तक जो मैंने बताया उसके हिसाब से बताओ कि if you want to reduce the deflection, now I will draw the horizontal line. Now this is your deflection, vertical deflection. If you want to reduce this deflection, what we will do? क्या करोगे आप? I want to reduce the deflection of the footing.
Increase in depth.
Correct. So definitely you know that if this D is more, then you can control. So what I will do, I will increase this depth like this. So whenever I increase the depth, this D is more and the deflection will be less. When I increase D more, that means I more. Finally, I is important term, moment of inertia. So increase the moment of inertia in that direction and control the deflection. Similarly for beams and slabs. Now deflection of slabs also you can see such kind of deflections are there. Due to vertical load, definitely the thickness of, how can you control the slab deflection? How to control?
The thickness of beam.
Increase
thickness of beam.
Thickness of the slab. See, I am not discussing anything regarding the concrete grade or steel reinforcement, number of bars. It is nothing to do with the reinforcement. Mainly I am saying, majoritarily saying, 90% of the deflections are controlled by only increasing the moment of inertia. That means depth, indirectly. You can increase the width also, there is no problem, but depth will be very much important because D cube by 12. So D ज़्यादा बड़ा है तो बहुत, the moment of inertia will increase a lot. If you increase the B, there will be increase, but it is not much. So your eye should be on the D, depth. Yes, so there are a lot of, see how thin slab thickness is here. Kitna kam thickness hai. So people don't understand this term and they do the blunders in this, we can say, market. You will see these blunders nowadays also. Even though technology is there, there are a lot of softwares, we do the analysis and design and all these things. Still there are blunders. Why blunders happen? Due to lack of basic concepts and common sense. Don't forget this, common sense is very important actually. Many civil engineers are there who have taken the degree B civil M.Tech structures, but they lose the common sense and they do such kind of mistakes. What he will do the analysis in the ETAB or STAD. He will do the steel reinforcement design, everything steel and everything, and he will say it is okay. But he forgot to calculate the deflections. He forgot to check the deflection in the softwares, and he did such kind of mistakes. So there are mistakes or blunders done by the engineers also. See, if there are no engineers, definitely there is more possibility of blunders, but if there are engineers, still it is possible due to lack of basic concepts and common sense. Okay, so doesn't mean that you are engineer, that means you don't do any mistake. Yes, it is possible, at least in the beginning of the career,